So in the previous video, I showed that when I am bringing the charge scale below this system of papers, then the space between these papers is increasing. And thanks for the comment, and indeed, this is right. It's actually due to polarization. Now, for someone who does not have a good idea in electrostatics, then he or she will find it hard to understand. So I will go step by step. So, in order to understand what is happening here, we have to understand two concepts first. Number one, the concept of electric field and its influence on different charges. And number two, the concept of dielectric substance. After these two concepts, you can easily understand what is polarization and what is actually happening here. Well, so let's start. Topic 1, that is electric field and its influence on different charges. First of all, what is an electric field? Well, let us understand this with some experiments and examples. Consider here is a book, and now I am going to move it. I moved it. How am I able to move it? Answer is very simple. I first made a contact between my hand and the book. Then I pushed my hand. As a result, my hand gave a force on this book, and the book moved. Now in the second case, I am still moving my hand, but I can't move the book, right? Why am I not able to move the book? What is the reason? I mean, in the first case, I was able to move the book by moving my hand. In the second case, even I am moving my hand, I am not able to move the book. What is the reason behind this? The answer is very simple: contact. Right? Contact. The answer is contact. So that means, can I conclude this? That in order for the force to act between two bodies, suppose these are two bodies, this is a body and this is a body, an object, whatever. Now this object will give a force on this object. That means, from the experiment, it is clear that for the force to act between two bodies, there must be a contact. There must be a contact like this between the two bodies. If there is no contact between the two bodies like this, then a force can never act, as I showed in my experiment. Now I know that who are watching this video carefully, they will ask me one thing, or anyone who would have given me this explanation, I would have also asked him this question, that how does the sun affect earth? How does the proton affect an electron? There is no contact between sun and earth, right? There is no contact between sun and earth. There is no contact between a proton and an electron, right? So how does the force even act between them? Moreover, if I make this question more interesting, does interaction between the sun and the earth or the proton and an electron happen instantaneously? I mean, suppose if I place sun here, this is sun, and if I place earth here, this is earth, then will the interaction between them happen instantaneously? Now all those answers can be given by the concept of electric field, or rather, don't say electric, rather the concept of field in physics. The concept of field in physics. Now, what is field? Let's understand with an analogy. Well, a field means simply a region of influence. Now, what does this influence mean? Well, this influence can be of different types depending upon the cases. Now, in this case, or the case that we are discussing, this influence is actually force. So, a region of influence, whose another name is field, this region of influence is certain region in space around an object. So if this is space, and if I keep an object here, then this object is developing a certain region in space around it, such that if any other object, suppose this is another object, if any other object is falling within this field of influence or a region of influence. Now let me tell one thing before I continue, that these two objects may have the property of charge or the property of mass. So if any other object, this object that I have kept, is falling within its region of influence, then they will start to interact with one another. See, in this interaction, there was no contact between them, right? There was no contact, but they still interacted with one another. Why? Because of these objects, field of or a region of influence. Now this object is not falling within the region of influence. Now I'm keeping it here. As simple as that. Now let me tell you one thing, that this is a very simple representation on the idea of the region of influence. This is not the way of how the electric field actually works, but this is a very simple idea of the region of influence and how non-contact forces work. Now in this case, the region of influence is very small. Remember that actually the region of influence actually extends up to infinity mathematically. Now in this small area I can't show infinity, right? So I've developed this representation in such a way that this is infinity point. See, if I keep it in infinity, at infinity, then there is no force among them, force acting between them. But as the distance between them is less than infinity, then a force acts between them. Simple. So now let's come back to the concept of electric field. So if I place a charge in space, suppose I'm considering a positive charge here, then it will create a certain region of influence in space around it. We call it the electric field, such that if any other charge is falling within this region of influence, and also please note that this charge also has its own region of influence or electric field, then they will start to interact with one another, or they will give a force on one another. Now a very important point to note, that here suppose I am considering this as charge A and this as charge B, then the electric field of charge A will influence charge B, while the electric field of charge B will influence charge A. Don't confuse this that electric field of A is influencing A. No, electric field of A can never influence charge A. Electric field of A can only influence some other charge. Here it is charge B. And the electric field of B can never influence charge B. It will always influence any other charge. Here it is A. That means the electric field can never influence its producer. The charge that is producing the electric field, its own electric field can never influence it. It can only influence any other charge which is placed within the electric field. Now one thing to note, very important, that this interaction does not happen instantaneously. You see here that if I place charge B, it will take some time to develop its electric field. Similarly, if I place charge A, it will take some time to develop its electric field. So this interaction between charge A and charge B does not happen instantaneously, but it takes some time. And this time is actually equal to d by c. D is a straight line distance between the two charges and c is the speed of light. Actually it happens at the speed of light. And this concept is in accordance with the special theory of relativity. Now you all might be wondering that what are those lines, right? See, actually these lines are electric field lines. Now electric field lines are actually imaginary lines. They are actually used to visualize the shape or how the electric field is distributed over space. Actually, different charge or charge systems will have different types of electric field distributed over space. Now this is important because if we want to determine the electric field intensity or measure how much is influence at a point in space at some distance from a charge system, then we have to visualize the electric field or how the electric field is distributed over space, and for that we use electric field lines. Now in the experiment that I showed, there I don't need the concept of electric field lines or electric field intensity, because here we are doing a qualitative analysis, not a quantitative analysis. I'm just explaining here that what is actually happening here and how this is working. Now to measure that, there are multiple equations and all. So whatever, Now what about those arrows? What those arrows represent on those electric field lines? See, as I said, that electric field lines serve the purpose of visualizing of electric field, how is it distributed over space, and how can I calculate the electric field intensity by this electric field lines at any point from a system of charges or a charge. Apart from this, it also helps us in determining the direction of the electric field at any point. See, if this is an electric field line, now this is curved, okay, now this is curved here. Electric fields may be of any shape, it may be curved, it may be straight line, whatever. So this is a curved, and I saw the direction like this, I saw the arrows like this. Now if you draw a tangent at any point on this line, then this arrow actually represents the direction of the tangent, and this actually in turn helps us in determining the net direction or the direction of the net electric field at this point. Well, now let's understand the interaction of different charges in an electric field. Now different charges means actually there are two types of charges, positive charge and the negative charge. So if this is an electric field, I mean these are electric field lines representing an electric field, and from this it is clear that the electric field or the net electric field is in this direction. Then if I keep here a positive charge or a negative charge, then how will they be influenced? Now influenced in the sense that they will experience a force, that is obvious. But in which direction will they experience a force? Well, for this we need to understand a property of electric field lines. See here, as I said, these are electric field lines, okay, and they are going in this direction as I have shown in this figure. But now you can ask one thing, that from where did these lines originate? I mean, if I extend these lines up to infinity, then there is no charge there. And without charge, there is an electric field that cannot exist, right? A charge will create an electric field. Right? If there is no charge, there is no electric field. So there must be a charge, right? So from where did those lines originate? And where are they going? Where are they going to terminate? Well, remember, electric field lines always originate from a positive charge. If I keep a positive charge here, then these electric field lines will always originate from a positive charge. And remember, they will always terminate at a negative charge. This is a property of electric field lines, that they always originate from a positive charge and end at the negative charge. Now let's come back to the case that we are discussing. I mean this case of the electric field. Now you see that these electric field lines are in this direction, right? Now they are going to terminate somewhere. As I said, they are going to terminate the negative charge at a negative charge. So that means in this direction there is some negative charge, and you see they are coming from this direction, right? And I mean, as I said, they originate from a positive charge. That means if they are coming from this direction, that means there is some positive charge here. Okay, so now tell me one thing, a very simple question, that if I keep a positive charge and a positive charge, or a negative charge and a negative charge, then what will happen? I mean, if I keep like charges together, what will happen? It's obvious that they will repel each other. Now if I keep unlike charges, I mean if I keep a positive charge and a negative charge together, then they will attract each other. So here, if I am keeping a positive charge here, then this positive and this positive will repel each other, while this negative and this positive will attract each other. So that means this positive charge will experience a force in this direction. That means it is experiencing a force in the direction of the electric field. Now if I keep a negative charge, then the negative charge and the negative charge will repel each other, and this negative charge and this positive charge will attract each other. So as a result, this negative charge will travel in this direction. So we see here that this negative charge is traveling in a direction opposite to the direction of the electric field. So this is how different charges interact in an electric field. So thank you. This was a very small video on how non-contact forces work, what is electric field, and its influence on different charges. In the next part, we'll be understanding the concept of dielectric substance, and thus after that we can understand the concept of polarization and what is happening here in this experiment.